Today we're going to talk about how we use those critical values to be able to determine an extrema value, and this is called the candidates test, or some people like to call it the closed interval test for calculating extremas. Now these basically are your 3 steps in using this test. First of all, identify your candidates. So you'll need to look at the domain and determine if there are any endpoints. If there are endpoints, those endpoints could be extremas. Next, you'll want to find your critical numbers. And if you remember from last lesson, that is when the derivative is equal to 0. If that occurs, that's a critical number. And then also where the derivative is undefined. That could also be another critical number. And this is where extremas could occur, either at the critical numbers or at the endpoints. Secondly, once you've identified your candidates, now you're going to evaluate each of them at the endpoint. So you're going to evaluate the function at each endpoint and at each critical number. And basically you'll make an XY table, you'll list your endpoints and your critical numbers, and you'll find their Y values. After you've done that, then you'll examine your list. The least of these values is your absolute minimum. And the greatest of these values is your absolute maximum. This should make sense both numerically and graphically when you examine the graph. Now let's do a problem. Well, actually, hold on there. I have a question for you. So you will pause the video and answer the question box that will pop up on the right side of your computer. The question is, at what 2 places will a critical point occur on the interior of a domain of a function? Great, now you may continue once you've answered. So now we're going to do an example together where we actually find the extreme values using the candidates test. So the first thing I have to do is I have to examine the domain and look for any endpoints. So I can see here in my function, it's a rational function, so we don't want the denominator to be 0. Now there's also a radical in denominator, which that cannot be negative. So we know that the quantity 9 minus x squared, x squared must be greater than 0. So we're going to solve to see what those values look like. So I'll subtract 9 from both sides. When I divide by a negative, of course, we flip the inequality. And then I'll take the square root of both sides. The square root of x squared we know to be the absolute value of x is less than 3. Well, with absolute value, I'm actually teaching this in Algebra 1 right now. And with less than, it's going to be an and solution. So either x will be less than 3, and x will be greater than negative 3. So we can see then our domain is of an open interval from negative 3 to 3. So there are no endpoints. So we do not have to worry about any extreme values occurring at the endpoints. Now let's go ahead and find the critical points. Well, in order to do that, we must calculate the derivative of the function. Well, we know this function, we could rewrite it as a power. So it is the quantity of 9 minus x squared to the, my pen, I'm having issues. Come on, right? Negative 1/2. Sorry about this. I'm not sure why it's having problems. Okay, now we're going to take the derivative of this function. So we bring the negative 1/2 to the front, and then the inside quantity stays the same. And then we subtract 1, so we get negative 3/2. And then it's times the derivative of the inside, which would be a negative 2x. Now let's simplify this. We see the 2's reduce. Negative times a negative is a positive. So we have an x in the numerator over the square root of the quantity 9 minus x squared to the 3rd power. Okay, now critical numbers occur when the derivative equals 0. So when our numerator equals 0, we would have x equals 0. So that is one of our critical numbers. Now the other critical numbers occur when the derivative is undefined. So that would be when the derivative is undefined. So when 9 minus x squared to the 3rd power is equal to 0. So I take the root of both sides. I get 9 minus x squared, again, equals 0. Subtract, now this is looking very familiar, isn't it? Okay, so we get negative 9. So x squared equals 9. So I take the square root. I get the absolute value of x equals 3. So therefore, the other critical numbers are 3 and negative 3. Well, because we examined the domain, we realized that the domain cannot include 3 and negative 3. So the only candidate for an extreme value is the value 0. And so if I type in the value 0 and put the 0 into the original function, I get 1 over the square root of 9, which is 1/3. So 0, 1/3. So would that function be a minimum or a maximum? Well, if I look at the values as I continue to the right of 0, so like for example, when x is 1, when x is 2, when x is 3, we notice that my denominator is getting larger, which would mean you're going 1 over, wait, let me think that through again. So 9 minus 1 squared is 8, square root of 8. 9 minus 2 squared is 7, square root of 7. Square root of 6, square root of 5, square root of 4. Okay, so 2, 1, so actually it's getting smaller, right? So the value, since the denominator is getting smaller, my value is increasing to the right. Well, it would also happen if the values of x were negative. It would also be increasing to the left. So therefore, 0, 1/3 would be a minimum. Okay, now let us move on to, so again, I'd like you to answer this question. Relative extrema only occur at what points? Pause the video and then begin again. Now, a couple of vocabulary things we have to be careful of. When you are being asked the question, what is the maximum value? They are wanting the output or the y value because they want to know, like, what is your maximum profit? They don't want to know the year, they want to know the actual number, the value. Now, if it says where does the maximum occur, that would be asking for the input value, the x value. And last of all, if it says where on the curve is the maximum, that would be the ordered pair. So be careful when you're answering a question to know what they're looking for. Okay, let's try another example. How about if we have x to the 2/3? And we want to find the absolute maximum and minimum on the closed interval, -2 to 3. Well, that's nice. They give us the endpoints, so we're going to examine 3 and -2. So now let's take a look at any critical numbers. So we're going to find the derivative. So the derivative of x would be, bring the 2/3 to the front, 2/3 x, subtract 1, you get -1/3. So if we rewrite that, we get 2 over 3 to the 3rd root of x. Well, we can see that this function will never equal 0 because the numerator will not equal 0. However, we could get a 0 in the denominator so the derivative will be undefined when x equals 0. So that is a critical value. So 0 is the other value we must assess. So now let's evaluate this function at these 3 points. So if we have 3 to the 2/3, well, that's 3 squared, which is 9 to the 3rd root. I know it's a little bit bigger than 2. So it's going to be like 2, I'm having problems with this, 2-point-ish, okay? Because 8 to the 3rd root is 2. Okay, so 9 to the 3rd root must be a little bigger. Now 0 would just be 0, and -2, so -2 squared is 4. Now to the cubed root of 4, the cubed root of 1 is 1, and then the cubed root of 8 is 2, so the cubed root of 4 is going to be 1 point something. Okay, so which would be my absolute maximum? Well, we can see that when x is 3, you're going to have a maximum. And the absolute minimum then will be at 0. So when x is equal to 3, we have a maximum, and when x is equal to 0, we have a minimum. Now we could verify these values by using the calculator and getting a decimal approximation. Okay, now let us go along and let's do one last one together. Okay, this time we have a piecewise, which is a little unusual. Now we can see here we have a quadratic function, which we know to be continuous, and it's open down. So, maybe something like this. And then we have a linear function with a positive slope. So something like that, possibly, okay? Now, we have to determine the endpoints. Well, as you can see, there is no limitation on the domain as far as going toward infinity. And as you can see, both of these functions can continue toward infinity. So there are going to be no endpoints. Now, let's take a look at the derivative, okay? So when we look at the derivative of my piecewise, f prime of x, we're going to get 2. Now you will conclude this video by answering 4 questions. So press pause, answer it, and then you continue. Here's the first question. Now the second question is, why do the local minima and maxima of a function occur at its critical point? Why is not every critical point a local minima or maxima?